Hi guys, welcome to my YouTube channel. So today I'm going to discuss one of the SQL questions that is related to the tree related architecture. So this looks a bit tricky or complicated, basically for those who are beginners in SQL. But I will make sure that I will try to explain or keep things as simple as possible in order to make you guys much more understanding. So if you look at this table, right, so we have a single table which is tree, and we have two columns here. One is id and second one is parent id. So if you could see the structure, right, so this is the structure, and we can define any node as as the root node or the leaf node or the inner node. So the root node is nothing but if a node can be treated as the root node if it does not have any parent node. So here one is acting as a root node because it does not have any parent node on the top of that. And 3 4 5 are basically treated as leaf node because it does not have any child node. And 2 can be treated as the inner node because it has both the root node as well as child node. So I hope you guys have understood the tree structure. Now if you could see the input, right, so we have two tables, sorry, we have two columns, id and the parent id. So as I said, that one is the root node because it does not have any parent node. So here the parent node is null for one, and for two it has parent node one. For two, parent node is one. Likewise for root node 4, sorry, for id 4. So this is having 2 as its parent node. So if you see the output, right, so basically we have to add one more column type, and we have to just specify that which node belongs to which type. So here one belongs to root node, two inner, and 3 4 5 are considered as the leaf node. So if I have to write the logic on that, so what we will do here is, so here we will have to write three logic. One is for root, second is for inner, and third is for leaf. So let's start with writing the logic for root node. Just selecting id. So in output I have id and type. So root as type from my table name, it is tree, where id is null. So this is how we define root node, right? So a root node is something which does not have any parent node. So we have written the logic. So if we run this particular code, right, see, we have got the wrong answer because we have not completed our query yet. But just to show you guys that we have got an output, a single record which is for root one root. So this is satisfied. Now we will be writing a logic on, let's say, leaf node, right? So what we will do here is just take this particular code and write it here. Replace root with leaf. And now what is the meaning of leaf node? Leaf node is something which does not have any child node, but it has a parent node. So one thing is for sure, that no, the parent node will not be null, right? Because it has the parent node. But this is not sufficient to identify whether a node is a particular a leaf node or not. We have to write one more condition here. Let's write it id not n. So I will explain you later. Let me write this down. Id from where id is not null. Let me validate this once. So yes, I think this is correct. So leaf node is nothing but it's a node which does not have does not have any child node. It has only parent node. So this one, for that we have written one condition, and second condition is that if you could see we have three leaf node, right? Just see the diagram and you will get to know that we have only three node, 3, 4 and 5, right? So 1 and 2 are not considered as a leaf node because these are the parent node. And if you see this particular table, right, PID, so we will not be having any entry for 3, 4 and 5 because these are the child node, and only 1 and 2 we will be having an entry, right? You could see 1 and 2 are having an entry, and rest 3, 4, 5 do not have any entry in this particular column parent id. So what we have to do is, what we have written is, first we have selected all the ids, distinct ids, sorry, distinct PIDs from tree, and we are excluding it by just selecting not in. So if we exclude it, right, so what we are doing is we are just excluding 1 and 2 because 1 and 2 are the only nodes that are considered as parent node. So we are not selecting it, and except those two nodes we are selecting all the nodes. So this is the logic for that. Understood? And just place a union between these two, and let me try to run this code. Now if you could see this output, right, so we have got a root node which is 1, and we have got 3, 4 and 5. If you would see, we have got 3, 4, 5 as the leaf node. So the only thing which is remaining is the inner node. So what we will do here is just write one more union here. And what you can do here is you just select all the queries from the leaf node, and you just have to remove this not in as, and because the above two logic that you have written, right, so one for the root node, one for the leaf node. So what is remaining here? So the only thing which we have remaining is inner node, right? So we have written the logic for this, we have written the logic for this. So we just have to replace not in with in, and we will get all the inner nodes that are present in this particular table. So let's run this. So yes, my answer is accepted here. The output which I was expecting is same as which we are getting here. So I hope you guys have understood this particular questions. This is mostly asked in top product based companies. So just try to go through this code once again. Try to practice this, and if you have any questions, just let me know in the comment section.